Hey folks, Mr. Hartzler here. I want to talk to you about creating sine waves and cosine waves and how to look at their graphs and determine what the equations are going to be. So the first thing I want you to notice is the sine wave up here. We cross our origin, we go up, we cross through our x-axis at 180 degrees, we go down, and we come back to 360 degrees. So because we start and end in 360 degrees, our period length is 360 degrees. Looking down at the next one, this has a couple more variables involved. We have A and we have B. The A represents our amplitude, and B gets factored in there a little bit to make our period. So amplitude is just the absolute value of whatever A is. The period length is based on 360 degrees divided by the absolute value of B. And we get into how all of that plays into what the graph looks like in the future. On this one here though, you'll notice that our B value would be a 1. 360 divided by the absolute value of 1 is 360, and that's another way we know that the period length here is 360. Another version of that is with radians. So instead of 360 degrees, we use 2 pi radians divided by the absolute value of B, and that also equals your period. For cosine, a lot of this is the same. Again, we're just switching out sine with cosine. And then up top, the graph is where we see the biggest changes. Instead of crossing at the origin, we cross up at our maximum value. We come down, we reach a minimum value at 180 instead of just crossing our x-axis. And we reach our maximum value at 360. So again, we're completing one full cycle in 360 degrees, so our period length is the same, but we are starting at our max instead of starting halfway through, or what is considered our midline. Let's go into looking at some examples. So in this one, we are finding the amplitude and the period. The amplitude comes from a number out in front. So we have the absolute value of A. A in this case is the 1/2. What is the absolute value of 1/2? Well, that is still just 1/2. So our amplitude is 1/2. That means we go up. If we call this, I like to label that one 1/2, and this one down here is going to be negative 1/2. The amplitude just shows us how high and how low we're going to go on our graph. Then we're going to look at this 2 in here. We're going to stick with degrees for now. 360 degrees divided by 2 gets me 180 degrees. So that means that our whole cycle is going to happen within 180 degrees. What I like to do, and what I think is the easiest, is I'm going to do a general sine graph. Then I'm going to go in and fill in what my degrees are. So I start at my origin. I need to go up. I need to come back down. Go down to my minimum. Come back through. And that's one cycle. And then we would keep going up and down and back around. I've now done 2 cycles. I didn't quite get down far enough on that second one. Now if one cycle is completed in 180 degrees, then from here to here, that's one cycle. So this is 180 degrees. Where would I cross right here? Well, that's going to be halfway in the middle. What's in the middle between 0 and 180? Well, that's 90. This one, what's between 0 and 90? That's going to be 45. And what's between 90 and 180? 135. And then you can keep going all the way out, and this one should be 360 degrees. And hopefully we understand by now that this goes infinitely long in both directions. Alright, so that is based off of a pretty simple sine graph. If I had, for some reason, a +3 on the end, all of this would get shifted up 3. So now the midline right here, instead of being at 0, would be a 3. This would be 3.5, and this would be 2.5. Alright, so we've done one with sine. Let's go on and do one with cosine. Our amplitude from this one still comes from our first number. So that's the absolute value of 3, still a regular 3. So I'm up at 3, down at negative 3. Our B value is a little bit more complicated. 360 divided by 2/3. Oh, sorry, the absolute value should just be on the bottom. So that's 360 times the denominator's reciprocal, or 3/2. 360 divided by 2 is 180. I still have to multiply that by 3. And that is 360 plus another 180. So that's 540. That's one full loop. So again, I'm going to start off just by drawing a general cosine graph. I start up at the top, and I'm going to come down. I've reached my bottom. I come back up, and I keep going in both directions. The end is now going to be 540. I need to cut in the middle of that, and that's 270. And I can keep cutting that in half to find each of my other pieces. So that would be 100 and then half of 70. So 145. And 270 plus 145. We have 415. And that's starting to fill in all of our little pieces, and we can keep going around our unit circle to get another loop. Now that is taking our function, our equation, and creating the graph. Now let's do it based off of our graph and find our equation. So those numbers are a little hard to read, but this first one is 180. This last one here is 360. First thing you want to know or note is it going to be a sine graph or a cosine graph? And in this case, because we're starting off high on our y-axis, we're starting up at a maximum, I know I'm going to be looking at cosine. Now I need to note what is that maximum, and in this case that's a 1, that's a 2, so this is a 1.5, 1 and 1/2, or 3/2. Cosine, and then how long does it take to finish one period? Well, in this case it's nice, it's still a 360. So I put 360 divided by my period length. I still get a 1. So I have 1 and 1/2, or we should probably write that 3/2, cosine of theta. Now let's go on to our next one, and that's this one down here. First, is it sine or is it cosine? Well, it's definitely a sine graph because I cross at my origin. Then I need to determine my amplitude. I go up to 5 and I go down to -5. Looks like I'm actually a little bit short on this one, but I should go down to -5. So my amplitude is 5. Then I need to figure out what my b value is. So 360 divided by my b value equals my period. What is my period in this case? Well, if I'm starting at the origin, when do I complete my first loop, or my first full trip? I go up and down and around to here, and then I repeat again. So my period length is from 0 to 180. Well, how much is that? 180. So that goes for my period. 180 equals 360 divided by my b value. Solve for b, so I can cross multiply. 360 equals b times 180 divided by my 180, and b equals 2. So now I have 5 sine, 2 times theta. So this is the equation that produces this graph here. Not too complicated, not too tricky. Sine and cosine, pretty typical. Tangent starts to get a little funky. I don't talk about this one because this is an Algebra 2 class. I don't talk about tangent a whole lot with them. I kind of save that for the geometry or the pre-cal teachers, whoever kind of gets to that first after me. But this is sine and cosine. The graphs aren't terribly complicated. And we'll go through an exciting little project with Ferris wheels, and I have my Principles of Engineering kids build actual Ferris wheels that run off a motor and everything. And it's going to be a fun little project. This will be my first year doing it, and hopefully it goes well. But this video should hopefully help out everybody that might be absent on the day I talk about cosine and sine graphs, or just to get a little bit of extra help in there. Hope this was helpful, and if it was, please click that like button. Subscribe to the channel if you like what you see and you want to see more of it. And as always, you can follow me on social media. Instagram is Mr. Hartzler, Twitter is Mr. Hartzler Math, and have a great day, everybody.